We're going to be looking at how to solve a square root equation, and it's exactly like it sounds. It's an equation that contains some sort of square root in it. You may have done some before when in geometry when we talk about the distance formula, trying to find certain values. In this case, we're going to have a variable, and we're going to need to make sure we use our inverse operations to help us figure out those answers. So a lot of times, again, when you're trying to do an square root, if you want to do the inverse of a square root, you are going to have to square. So we will be squaring all these equations because they contain a square root to help us get x by itself. So we're going to look at b, d, and f together. And you want to isolate. One of the biggest keys is just isolate, get the square root by itself. Now there may be more than one term underneath it, but you want to just get that square root by itself. So like in the case of b, it is. There's no other terms near it. We'll see different things happen in d and f. So if you go ahead and square both sides, we're going to square this side. We're going to square the other side as well. That'll cancel out that square root, giving you just x minus 3. And then 5 squared will be 25. So that means that x, by adding 3 to both sides, is going to be 28. And again, you can perform checks to figure out if the answer is correct. So if you do the square root of 28 minus 3, you type that in the calculator and see if that gives you 5 out. Okay, and this one, in fact, will. I'll throw it in there quickly so you can see it. So if you use square root of 28 minus 3, you get 5, like we just talked about. So check's a good way, especially the first few, just to make sure you're doing it right. Plug in the number and see if it works. Now with D, I'll do this one in red. We have a square root of x. We want to try to isolate the square root of x, get that by itself. So again, we're going to do inverse operations. You'd want to add 4 because there's a minus 4. Any term separate, you want to get rid of that one first. So we have 3 radical x equals 24. And that 3 is connected to the radical x by multiplication. So you're going to want to divide both sides by 3. So we have square root of x equals 8. And once you have that square root by itself, you go ahead and you square it. Square that and square the 8. It's going to give us an x value of 64. So if I do 3 radical 64 minus 4, do I get 20 out? So again, I'll type that one in. So we got 3 radical 64 minus 4. And we get that 20 that we had in our equation for D. Now the last one we're going to look at is F. So for F, same thing. I'm going to isolate this square root. I'm going to add 4 to both sides. So I have 5 square root of 3x minus 2 equals 40. Think of that square root as one term. You're just going to try to keep everything with it that's under it. 40 divided by 5 is going to be 8. Okay. Now again, we would square once we have the square root by itself. So we have 3x minus 2 equals 8 squared, which is 64. You still got to get x by itself, so we got a couple more steps we're going to have to do. We're going to have to add 2 to both sides, so you get 3x equals 66. And then divide by 3, so that x is 22. And again, you can plug in the 22 where the x is. Put it in parentheses right there. Should give you a 36 out. So those are some of the basic ones. And again, you're using some of the properties of equations. You're adding, subtracting, multiplying, dividing, doing the opposite of what you see. Now we're going to look at a graph, because we've been doing graphs as well this year. So if we go over to the back of this page, look at exercise number 3. It says consider the system of equations shown below. So we're going to graph each of those onto this grid. Now x plus 1 I know, because it's got a y-intercept of 1 and a slope of 1. So I'm going to go ahead and throw that one in. I'll draw that. That's y equals x plus 1. Then I'm going to go ahead and type in the other one, which is square root of x plus 3. Let's make sure I type that in right. Yep, we're good to go. Second graph. Looks like we start at negative 3, 0. I'll do this one in blue. We got negative 3, 0, negative 2, 1, 1, 2. And move down a little bit, get another number in here. There we go, 6, 3. 6, 1, 2, 3. So if we're talking about a system, it looks like right here we have a solution at 1. When x is 1, when x is 1, we have an answer, we get a y value of 2. So 1 looks like it'll be a solution for this because of the point 1, 2. Now it says to solve the system algebraically. Now it says there's one value right now, but let's go ahead and solve this algebraically. So we're going to use substitution, and we're going to set those two equations equal to each other. Now you'll notice that I have the square root by itself, so I can square both sides of this. Okay, so I have x plus 3 over here. And then just be careful with this, because you're going to have to FOIL this. You're going to have to distribute. And this will actually end up being x squared plus 2x plus 1. So, and again, I'm getting that from the idea of x plus 1 times x plus 1. Now I'm going to go ahead and isolate my right side. So in the case of this, I'm going to get everything with that x squared. So I'm going to subtract the x and subtract the 3. So I'm subtracting a 1x and subtracting 3. It's going to leave me with a 0 on the left, which I want, so I can solve. And then I have x squared plus 1x minus 2. And again, I'm going to factor. So using some of the tools from Unit 6, our last unit we talked about, this will end up factoring into x plus 2 and x minus 1, which means I have zeros at negative 2 and 1. So now it says I have two answers, but we just found in the system, on the graph, we only had this answer. So they're saying this one, not going to work. So why does that contradict what we talked about? Well, the idea with this is that, again, a square and a square root are opposites. But you'll notice, if we had a square or a quadratic function, that quadratic function would have hypothetical points on the other side. So imagine this, me drawing this out, it does look like a parabola. It does kind of resemble that shape. So the big idea here is that we may come across some answers that don't work because of the nature that we can't have a negative square root. So if I went to a value for that, what will happen when I plug it in and check? It will not actually check. So if you do see answers that have two, or see square root equations that have two answers, make sure you check both, because one of them may not be right. Okay? So, if you have questions on this as you're working on the next couple of pages, please feel free to ask me in class, and good luck.